Review video number 2, bridge circuits A. There will be another bridge circuits video later, so that's why this one is video A. Here's our bridge circuit, and we want to determine each of these quantities when the switch is open, as shown here. It's always useful to color code, at least mentally, our circuit, and this is the symbol for ground, so that means that that is 0 volts of pressure. All of this region of the circuit right here has the same electrical pressure, and then all of this region has the same electrical pressure of 36 volts. So I'll circle that right there, and then 0 volts of pressure right there. And then the rest of the circuit, let's see, if this is open, then this portion has a certain electrical pressure, and then this portion has some fourth electrical pressure, which we don't know yet. Let's see if we can answer any of these questions. The current going through the 4 ohm resistor, there won't be any, because with this switch open and a capacitor right here, there's not going to be any current going through there. How about the current through the 8 ohm resistor? Same thing, 0 amps. Okay, well, this is easy so far. How about the voltage across the 4 ohm resistor? Well, if this is a capacitor and this is a capacitor, and there is no charge that can flow anywhere in the circuit, essentially what happens is that this region of the circuit becomes pressurized, equal to 36 volts as well. This whole thing becomes 36 volts. And the same sort of thing happens down here. When no current can flow, in pretty short order, even the electrical pressure of this region is going to be 0. When this switch is open, there is not a whole lot going on in terms of flow of charge. In fact, there's basically nothing going on, which means the voltage across this 4 ohm resistor, if there's no current going through it, there's going to be no voltage difference across it. Same thing here. If there's no current going through this 8 ohm resistor, then there can't be a voltage difference from one side of it to the other. However, there will be a voltage difference across this 3 farad capacitor, and that will be 36 volts. By the way, we usually use nanofarads or microfarads maybe. 3 farads is a very large amount of capacitance, but I just chose the numbers so we didn't have to have any SI prefixes in there like nano or micro, just to kind of make things easy. All right, across the 6 farad capacitor, same voltage difference, 36 volts. Now, is there charge going to be stored in these capacitors? Absolutely there is. And how would we figure that out? What's the equation? Capacitance is charge over voltage. Therefore, charge is going to be capacitance times voltage. I'm thinking here capacitance of 3 times 36. I'm thinking that's going to be 108 coulombs. And then over here, I think we're going to have the capacitance of 6 times 36, which is 216 coulombs of charge. When the switch is open, that's what you've got. When you close the switch, then what happens is this portion of the circuit still has an electrical pressure of 0 volts. This portion of the circuit, there must be a battery or some sort of voltage producing device in here somewhere, but it's not shown. That portion is 36 volts of electrical pressure. But then once the switch is closed, this whole center portion is going to have a uniform potential, some voltage that we don't know right off the top of our heads here. Okay, there's a path that current can flow through here. It's going to make kind of an S shape, and the total resistance of that path is 4 plus 8. So that's a resistance of 12. Let me write that up there. Resistance is going to be 12 ohms, which means the current flowing through the 4 ohm resistor as well as the 8 ohm resistor is 36 volts divided by 12 ohms. So that's going to be 3 amps. 3 amps going through there. The voltage across the 4 ohm resistor is going to be I, 3 times 4. So that's 12 volts. The voltage across the 8 ohm resistor is going to be I, which is 3, times R, which is 8. So that's 24. And look at that. There are your 36 volts dropping from the top of the circuit to the bottom. It drops 12 at first, and then it drops the final 24. Which means, and if you look at the picture here, you can see with the help of the colors that the voltage across the 3 farad capacitor is the same as the voltage drop across this resistor, which is 24. Similarly, the 6 farad capacitor has the same voltage drop. You see, red to green, and red to green we decided was 12. So that's 12. And the charge stored on the plates, one more time, what was the equation for charge? And just bring it back here. Oop, there it was, right there. See, the charge is the capacitance times the voltage. If I rewrite that here, the charge is the capacitance times the voltage. For the 3 farad capacitor, it's going to be 3 times 24, which is 72 coulombs. Quite a bit of charge, actually. Similarly, the charge here is going to be, capacitance is 6, voltage is 12, so that's going to be 72 coulombs. Okay.